Welcome to The Explainer. Today, we're diving into one of the biggest, most exciting shifts in AI, the jump from AI that just talks to AI that actually does things. We're going to trace the whole story of agentic AI, all the way from a philosophical idea about human choice to the powerful autonomous systems that are starting to reshape our world. For years, we've gotten pretty used to AI that can answer our questions, maybe write an email for us. But the real revolution, the thing that's happening right now, is built on a much, much bigger question. What if AI could take all that information and actually do stuff in the world for us? So to really understand how we got here, we've got to rewind the clock a bit. And what's kind of wild is that the core idea of an agent wasn't even born in a computer science lab. Not at all. Believe it or not, the whole concept of agency comes straight from psychology. Way back in the 80s, a psychologist named Albert Bandura defined it as this core human thing, the drive to make choices, to act on purpose, to have an impact on our world, instead of just letting it happen to us. And this is where computer science steps in. They took that very human idea and gave it a technical blueprint. In their legendary 1995 textbook, Russell and Norvig laid out this beautifully simple framework. An agent senses things, and an agent does things. That one sentence basically unified the entire field and gave everyone a common goal to shoot for. But of course, just sensing and acting isn't enough, right? To be truly intelligent, an agent needs a few more tricks up its sleeve. It has to be autonomous, operate without someone holding its hand. It needs to be reactive, to handle curveballs the world throws at it. It has to be proactive, chasing its own goals, not just responding. And it even needs some social skills to work with us and other agents. These four things are what separate a simple program from a real AI agent. Okay, so once everyone was on the same page about what an agent is, a massive fight broke out in the AI community about the best way to actually build one. It was basically a clash of philosophies, a battle between two totally different ideas about what intelligence even looks like. On one side, you had the planners, the deliberative agents. Their whole motto was think, then act. They build these incredibly detailed maps of the world inside their heads and plan out every single step. Then, on the other side, you had the doers, the reactive agents. Their philosophy was basically just do it. They skipped all that complicated planning and just reacted, in real time, to whatever was right in front of them. Robotics pioneer Rodney Brooks just perfectly captured the whole spirit of the reactive camp with this quote. He said, "The world is its own best model." I mean, what a line, right? He was basically saying, why waste all this time and energy building a complicated, fake version of the world inside a computer's memory when the real one is right there? Just use your sensors and look at it. It was a totally radical idea, and it changed the game. But at the end of the day, neither approach was the perfect solution. The reactive systems were super fast and nimble, but they couldn't plan for the future to save their lives. And the deliberative systems were brilliant long-term thinkers, but they were slow, and if anything unexpected happened, they would just freeze up. So what happened? Well, as it often does, the answer was a compromise. Researchers realized they needed the best of both worlds. They started building hybrid systems that had a fast, reactive layer for dodging obstacles and handling immediate stuff, and a slower, deliberative layer on top to think about the big picture and manage long-term goals. This hybrid model was pretty good, but something was still missing. The field had basically built the body of an agent, but it was still waiting for the right kind of brain. And then, large language models came along, and absolutely everything changed. See, the LLM wasn't just another component. It was the cognitive backbone that the entire field had been searching for. All of a sudden, we had this flexible, general-purpose reasoning engine that could understand goals, make complex plans, and adapt to new situations in a way that no system before could have even dreamed of. And that new brain enabled what we now call the modern agent's core loop. It's this beautiful, continuous cycle. First, it observes the world, pulling in data from all over. Then the LLM thinks and plans a course of action. Next, it acts on that plan using different tools. And finally, and this is the crucial part, it learns from what happened to get smarter for the next time around. Observe, plan, act, learn, over and over. So, if you were to pop the hood on one of these modern agents today, these are the key parts you'd find. You've got the LLM, which is the brain doing all the thinking. You've got memory, both for what's happening right now and for what it's learned in the past. You've got tools, which are basically its hands for interacting with the digital world. And then you have orchestration, which is kind of like the conductor of the orchestra, making sure all the pieces work together perfectly. But, and you knew there was going to be a but, right? This incredible new power doesn't come for free. As these agents get more and more capable, we're starting to run into a whole new frontier of challenges, both on the technical side and, maybe more importantly, on the ethical side. On the technical side, it's funny. The biggest problems aren't even the AI itself. It's the messy real world we're trying to plug it into. Data is scattered everywhere in different formats. A lot of old infrastructure just wasn't built for this kind of thing. And just trying to scale up and run thousands of these agents at once, it's a huge engineering headache. And that leads to an even tougher set of questions. When an agent, working all on its own, makes a mistake, deletes the wrong files, sends 1,000 angry emails, who is responsible? The person who told it what to do, the developer who built it, the company that owns it? This is what people are starting to call the accountability gap. Our laws and social rules just haven't caught up with the tech yet. Then you've got the risk that agents could take hidden biases in their training data and amplify them in the real world. And there's this really chilling new threat called a silent attack vector. Think about it. An attacker could subtly change some information on a public website, knowing an AI agent will read it and be tricked into taking a malicious action, without ever having to hack the agent directly. That's a whole new kind of vulnerability. So here we are. The technology is evolving at a dizzying speed. The fundamental question we're all left with, the one we have to figure out, is whether our ability to govern it, to build the right guardrails, to answer these incredibly tough ethical questions, can possibly keep up.